What happens when the most dangerous choke point on Earth stops being Iran's weapon and starts being Iran's nightmare? What happens when the minefield designed to hold the entire global economy hostage begins to drift? When the threat Tehran spent decades building, stockpiling, and publicizing turns around and points itself at Iranian tankers, Iranian ports, and Iran's most critical diplomatic relationships? That is exactly what we are going to break down today. And by the end of this video, you will understand why the Strait of Hormuz is not just a geographic vulnerability for the world. It is potentially the single greatest strategic liability Iran has ever created for itself. 21 million barrels of crude oil move through this body of water every single day. That is roughly 1/5 of the entire world's petroleum supply passing through a corridor that, at its narrowest point, measures just 33 kilometers across. That is about 20 miles. 2 inbound shipping lanes, 2 outbound, separated by a 2-mile median zone. Look at the map here. You can see how those lanes hug the Omani coastline to the south, staying as far from Iranian territorial waters as possible. Now zoom out. You'll notice there is no alternative. There is no bypass, no pipeline network, no rerouting option that can absorb the full volume of Gulf oil exports. The Strait of Hormuz is, by any objective military and economic analysis, the single most consequential maritime choke point in the world. Iran has known this for over 4 decades. Since the end of the Islamic Revolution in 1979 and accelerating dramatically during the tanker wars of the 1980s, Tehran has treated the Hormuz corridor as its ultimate asymmetric trump card. The logic is elegant in its brutality. The US Navy outclasses the IRGC Navy in every conventional metric: tonnage, firepower, electronic warfare capability, carrier aviation. But none of that matters if Iran can make the strait physically impassable. And the weapon that makes it impassable is not a missile, not a submarine, and not a fast attack boat. It is the naval mine, one of the oldest, cheapest, and most operationally disruptive weapons ever invented. This is stage 1. The decision to deploy comes after weeks of escalating tension. US sanctions have tightened again. Iranian oil exports are running at roughly 500,000 barrels per day, down from pre-sanction levels of over 2.5 million. The IRGC Aerospace Force conducts a missile drill in the Eastern Gulf. Washington responds by surging 2 carrier strike groups to the region, one positioned in the Arabian Sea, one in the northern Red Sea. The rhetoric from Tehran reaches a frequency and intensity that military analysts recognize as a pre-deployment posture. At 0200 hours on a moonless night, IRGC Navy fast boats, specifically the Thondor-class missile patrol craft and a fleet of smaller Boston whaler-style rigid inflatables, slip out of Bandar Abbas and Keshem Island under electronic emissions control. They carry a mixed payload. The first type is the M08 contact mine, a Soviet-designed spherical moored mine that dates to World War II but remains devastatingly effective. The M08 weighs approximately 560 kilograms. Its explosive charge of 240 kilograms of TNT is sufficient to hold any commercial tanker below the waterline. The mine is deployed on a cable anchored to the seabed, floating at a preset depth, typically 2 to 3 meters below the surface, invisible from a ship's bridge, nearly impossible to detect by radar, and lethal on contact. The second type is a pressure-influenced bottom mine, a more sophisticated system that rests on the seafloor and detonates when the hydrodynamic pressure signature of a passing vessel matches its trigger parameters. These mines are harder to sweep, harder to locate, and capable of targeting specific ship classes based on displacement. Look at the overlay here. You can see the deployment pattern in the eastern approach lane, the zone where outbound loaded tankers make their final turn toward the Gulf of Oman. The mines are placed in a staggered grid, approximately 200 meters apart, designed to create a denial zone roughly 12 nautical miles wide and 8 nautical miles deep. By 0530 hours, the operation is complete. The boats return to port. And at 0700, Iranian state television broadcasts an announcement: the Strait of Hormuz has been armed. The threat is real. The mines are in place. Oil markets respond within minutes. Brent crude futures spike 18% in the first 6 hours of trading. Insurance premiums for Gulf shipping, already elevated by prior IRGC harassment operations, surge by an additional $200 per ton. Shipping companies begin rerouting around the Cape of Good Hope. The Lloyd's of London Joint War Risk Committee formally designates the Hormuz approach zone as a war risk area. The global economic ripple effect is immediate and severe. This is stage 2. But here is where the plan begins to unravel. The Persian Gulf is not a static body of water. It is a complex, dynamic marine environment shaped by competing tidal systems, seasonal wind patterns, and a permanent thermohaline circulation driven by the extreme salinity of Gulf waters. In the summer months, a phenomenon called the shamal, a powerful northwesterly wind driven by the pressure differential between the Arabian Peninsula and the Iranian Plateau, generates surface currents that can reach 4 knots in the eastern Gulf. 4 knots does not sound like much, but over 72 hours, a 4-knot current moves a free-floating object approximately 520 kilometers. The M08 mines are moored. They are supposed to stay put, but mooring cables corrode. Anchor weights shift in soft seabed sediment, and when a current reversal hits a minefield at an angle, the lateral stress on anchor cables exceeds their rated tension. Within 72 hours of deployment, IRGC monitoring assets, a combination of patrol boat visual sweeps and a limited coastal radar network, begin detecting anomalies. Mine buoys that should be stationary are moving, not dramatically, but enough. By hour 96, the picture becomes undeniable. Approximately 40 of the deployed mines have broken free of their moorings. They are now unguided, uncontrolled, drifting with the current in an unpredictable pattern. And they are drifting south, away from the designated denial zone and into the general shipping lanes. The minefield has stopped being a tactical barrier and started being a random hazard. The first near miss happens on the morning of day 4. An Iranian-flagged LNG carrier, the Arvand, operating under a flag of convenience but beneficially owned by a Tehran-connected trading company, is transiting outbound at 12 nautical miles from Bandar Abbas when its lookout spots a dark, spherical object in the water 300 meters off the port bow. The captain orders emergency stop and hard starboard. The object drifts past. It is an M08 mine, unmistakably Iranian manufacture, still carrying its detonation horns. The report reaches the IRGC Navy Command in Bandar Abbas within the hour. And at that moment, Tehran faces a dilemma that has no clean solution. This is stage 3. If Iran publicly acknowledges that its mines have drifted, it destroys the deterrence narrative it spent years building. The entire strategic value of the Hormuz mine threat rests on the implicit claim that Iran can control the strait, that it can open and close this corridor at will, on its own terms. The moment Tehran admits that its own mines are drifting uncontrolled through international shipping lanes, that claim collapses. Iran would be admitting not that it holds a weapon over the world, but that it has dropped a weapon onto the floor of a crowded room. But if Iran says nothing and the mines continue to drift, the consequences could be catastrophic. Iranian commercial shipping, which, despite sanctions, still moves through the Hormuz corridor, is now at risk. Iranian fishing vessels operating out of coastal ports along the Makran coast and the Gulf shoreline could encounter drifted mines. And beyond Iranian vessels, any ship transiting the area is at risk. That includes tankers carrying Iranian oil to China, Iran's economic lifeline, and vessels chartered by companies with indirect ties to the Iranian state. Tehran chooses silence. For now, IRGC mine clearance assets mobilize immediately, but they face a structural problem that cannot be solved by willpower. Iran's dedicated mine countermeasure fleet consists primarily of a small number of Harishi-class and Lavan-class vessels, derivatives of Soviet-era Natia-class minesweepers, supplemented by a handful of auxiliary craft. These vessels use primarily mechanical sweeping systems, cables dragged through the water to snag moored mine cables and bring them to the surface for disposal. The technology is effective under the right conditions: calm water, shallow depth, stationary mines, known position. None of those conditions apply here. The drifted mines are mobile, unpredictably distributed across a 60 square nautical mile area in water depths ranging from 40 to 100 meters. The mechanical sweep systems on Iran's minesweepers have limited depth capability, and the vessels themselves, traveling at their operational sweep speed of 5 knots, can cover only a few square nautical miles per day. The mathematics are not favorable. With the available assets, full clearance of the affected area would take weeks, and the mines continue to drift. This is Stage 4. The U.S. Fifth Fleet in Manama, Bahrain has been watching. The National Geospatial Intelligence Agency has been tracking the mine deployment via satellite and maritime patrol aircraft for days. The P-8A Poseidon aircraft operating out of Al Udeid Air Base in Qatar, equipped with the AN/APY-10 maritime search radar and magnetic anomaly detectors, have been mapping the drift pattern with a precision that Iran's own assets cannot match. By day 5, U.S. Navy planners have a better picture of where Iran's mines are than Iran itself does. The order goes out from Fifth Fleet: activate the Mine Countermeasure Group. 4 MCM-1 Avenger-class minesweepers surge from Manama. These are purpose-built mine warfare vessels, 68 meters long, 1,300 tons full displacement, constructed with a fiberglass hull to minimize their own magnetic signature. They deploy in a sweep formation, 500 meters apart, methodically working the affected zone. Alongside them, a flight of MH-60S Seahawk helicopters launches from USS Bataan, an amphibious assault ship positioned 80 nautical miles south of the strait. Each helicopter carries the system that changes the tactical equation entirely. To understand how this works, let's crack it open. The AN/AQS-20 is a towed sonar system, meaning the helicopter doesn't touch the water, it simply tows the sonar body on a cable at low altitude, typically 20 to 40 feet above the surface. If you look at the sensor body itself, you'll notice it resembles a torpedo, roughly 2.5 meters long, 30 centimeters in diameter, weighing about 270 kilograms. Inside, it contains 5 distinct sonar systems operating simultaneously. The forward-looking sonar projects a beam ahead of the vehicle to detect mines in the direct path. The side-looking sonars, one to port, one to starboard, sweep a swath approximately 200 meters wide on each side, mapping the seafloor in real time. A gap-filler sonar covers the blind spot directly beneath the tow body, and the buried object detector uses a lower frequency beam that can penetrate soft sediment to find mines resting on or partially buried in the seabed. The system tows at up to 10 knots, twice the search speed of a conventional minesweeper, and generates a 3-dimensional acoustic map of the seafloor that the crew processes in real time via a digital display aboard the helicopter. When a mine-like object is detected, the system flags it, records its GPS coordinates, and generates a contact report automatically. Once inside the contact file, you'll see each detected object tagged by confidence level, high, medium, or low, based on its acoustic signature. A high-confidence contact looks distinctly different from a rock or a piece of wreckage. The spherical profile of an M08, the distinctive horn pattern on its equatorial band, the cable shadow extending downward to the anchor. All of these features appear in the sonar return with enough clarity for a trained operator to make an identification call in under 2 minutes. Confirmed contacts are then handed off to the Mark 18 Mod 2 Kingfish, an autonomous underwater vehicle, or UUV, roughly the size and shape of a torpedo, 2 meters long and 12.75 centimeters in diameter, weighing 53 kilograms. The Kingfish is deployed from the minesweeper, navigates autonomously to within 1 meter of the target, and conducts a close-range visual and acoustic inspection using its onboard camera and high-frequency sonar. If the contact is confirmed as a mine, a neutralization charge, typically a shaped explosive device, is placed by an EOD diver or deposited by the UUV itself and detonated remotely. The mine is gone. The crew moves to the next contact. The contrast with Iran's mechanical sweeping capability could not be more stark. Where Iranian minesweepers cover perhaps 3 square nautical miles per day with uncertain effectiveness, a single MH-60S with AQS-20 can survey 30 square nautical miles in the same time frame, with contact resolution accurate to within half a meter. The technological gap here is not a marginal advantage, it is a generational one. Iran is playing a mine clearance game with 1970s tools against a US system that was designed, tested, and refined specifically to defeat threats like the ones Iran just deployed. This is Stage 5, and this is where everything went sideways in ways that no one in Tehran, Washington, or Beijing had anticipated. On the morning of Day 8, a very specific ship appears on the AIS tracking screens of every maritime monitoring center in the region. It is the Kunlun Star, a 330,000 deadweight-ton, very large crude carrier flying the flag of a Chinese state-affiliated shipping company. The Kunlun Star is carrying approximately 2 million barrels of crude oil loaded at Karg Island, bound for Tianjin. It is transiting the outbound lane in exactly the zone where drift analysis predicts the highest mine density. But the mine drift prediction models, running on 72-hour-old current data, have not captured a subtle but consequential shift in the tidal cycle. A mine that the models place 4 nautical miles south of the shipping lane is actually 1.5 nautical miles north of it. At 0347 local time, the Kunlun Star strikes it. The detonation occurs at the vessel's port bow, approximately 3 meters below the waterline. The 240-kilogram TNT charge blows a hole approximately 8 meters wide in the double hull structure. The blast kills 2 crew members in the forward compartment instantly. The vessel does not sink. Its massive displacement and modern double hull construction contain the flooding, but it comes dead in the water, listing 8 degrees to port, 6 nautical miles inside Omani territorial waters, with 2 million barrels of crude oil at risk of spilling into the Gulf of Oman. The mine is Iranian. The evidence is immediate and unambiguous. Fragments of the M08 casing are recovered by the Omani Coast Guard within hours, and the IRGC designation markings are intact on recovered hardware. The Kunlun Star's flag state, China, has its embassy in Tehran on the phone within 90 minutes of the incident. But here is the thing. China is not just any flag state. China buys approximately 70% of Iran's oil exports, the very oil exports that keep the Iranian economy from complete collapse under US sanctions. China is Iran's primary diplomatic shield in the UN Security Council. China is, in the most direct and transactional sense possible, the reason the Iranian regime has been able to sustain itself through a decade of maximum pressure campaigns. And China's tanker just got sunk by an Iranian mine. The diplomatic fallout is immediate and brutal. Beijing's foreign ministry statement, issued within 24 hours, uses language that has never before been applied to Iran in public Chinese communications. It demands immediate clearance of all mines in the Hormuz area, full compensation for the Kunlun Star and its cargo, and a formal explanation of how Chinese commercial shipping came to be endangered by Iranian naval operations. There is no ambiguity in the language, no diplomatic hedging. This is Beijing telling Tehran, in terms that cannot be misread, that Iran's mine deployment has become China's problem, and that China expects Iran to fix it. But Tehran cannot fix it. That is the point. Iran's mine clearance capability is insufficient. Its diplomatic position, silence on the drift, is now impossible to maintain. And the option of asking Beijing to clean up the mess is so humiliating that it is barely thinkable. Beijing doesn't wait to be asked. Within 48 hours of the Kunlun Star incident, the PLA Navy Task Group operating in the Gulf of Aden, a regular rotational deployment ostensibly supporting anti-piracy operations, receives new orders. The task group includes a Type 081 minesweeper, the Linfen, 6,000 Zalo 10 tons full load, equipped with the PS-60 integrated mine countermeasure system, variable depth sonar, and a complement of remotely operated mine disposal vehicles. The Linfen transits the Strait of Hormuz and enters the Gulf, positioning itself in the mine-affected area. It begins sweeping operations. Iran is now being rescued by its most important ally from a crisis Iran created. The operation is not coordinated with Tehran. There are no joint press releases, no bilateral military agreements cited, no Iranian officers aboard the Linfen. China simply begins clearing Iranian mines from international waters, and Iran can say absolutely nothing about it, because saying anything means acknowledging that the mines existed, that they drifted, and that they were responsible for sinking a Chinese tanker. Look at this operational map here. You can see the 3 clearance elements working the affected zones simultaneously. The 4 U.S. Avenger minesweepers are working the western and central sectors. The MH-60S flights are covering the northern approaches near Iranian territorial waters, the zone where the drift originated. The Chinese Linfen is working the southern sector, nearest to Omani waters where the Kunlun Star went down. And threading between all of them, carefully deconflicted by back-channel communications that will never appear in any official record, are the EOD dive teams from USS Gladiator, a dedicated mine countermeasure support ship handling the confirmed high-value contacts that the sonars have flagged but that no one wants to leave to an autonomous system. This is Stage 6. Over the following 11 days, the combined clearance operation, never officially acknowledged as combined, never described by any participant as coordinated, neutralizes 34 of the 40 drifted mines. The remaining 6 are located in positions where their depth, the local current patterns, and proximity to shipping lanes make standard sweep procedures impractical. U.S. EOD divers from Explosive Ordnance Disposal Mobile Unit 3, the same unit that has been conducting mine clearance in the Gulf since the 1980s tanker wars, make the calls. Each diver descends to depths ranging from 40 to 75 meters, navigating by compass and dive light to the GPS coordinates provided by the AQS-20 sonar data. Each mine is manually assessed, a neutralization charge is attached to the explosive train, and the diver exits the blast radius. 6 controlled detonations, 6 mines destroyed in place. On day 11, the Strait of Hormuz reopens to full commercial traffic. Insurance surcharges begin to fall. Shipping companies that rerouted via the Cape begin calculating when it becomes economical to come back. Oil markets stabilize, and Iran issues a statement. 9 days after the Kunlun Star was hit. 9 days of silence while Chinese and American assets cleaned up the IRGC Navy's mistake. The statement claims that Iran's mines were illegally disturbed and displaced by foreign naval elements operating without authorization in the vicinity of Iranian territorial waters. It does not acknowledge that any mines drifted. It does not acknowledge the Kunlun Star strike. It does not name China, the United States, or Oman. It does not acknowledge that 34 Iranian naval mines were destroyed by foreign forces in international waters with zero Iranian authorization or involvement. No one in Tehran, Beijing, or Washington treats the statement as credible. No one needs to. The operational facts speak with a clarity that no statement can override. Look at the strategic picture now. You can see what Iran has lost. And it is not the mines themselves. 40 mines, even at the premium procurement cost of military-grade ordnance, represent a relatively minor financial loss for the IRGC Navy's operational budget. What Iran has lost is the credibility of the threat those mines represent. The Hormuz mine option only works as a deterrent if the world believes Iran can execute it, deploy mines, control the corridor, and force the international community to negotiate on Iranian terms. What this operation demonstrated in front of every naval intelligence service on the planet is the opposite of that. Iran deployed mines. Iran lost control of them. Iran's primary ally had its ship sunk by them. And Iran could not clear them without outside assistance. That is not a demonstration of deterrent capability. That is a demonstration of deterrent collapse. The strategic lesson runs deeper than this single incident. Asymmetric deterrence, the doctrine of using cheap, low-technology weapons to threaten disproportionate damage against a superior conventional force, depends on one thing above all others: credible control. The mine is a threat only if you can deploy it where you want, maintain it where you put it, and clear it when negotiations require. Iran demonstrated in this operation that it can do the first and perhaps the second under ideal conditions. But the third, the ability to control and remediate its own weapons in a dynamic maritime environment, is simply beyond its current capability. And that gap is widening. The US Navy's investment in autonomous mine hunting, the AQS-20, the Kingfish UUV, the follow-on A-list system currently in advanced testing, represents a generational leap in clearance speed and accuracy. What took a minesweeper fleet weeks in 1987 takes a helicopter detachment days in 2025. The technology will only improve. Iran's mine stockpile, by contrast, is aging. The M08 inventory dates to Soviet-era transfers and domestic manufacturing lines that have not been substantially updated. The pressure-influence mines are more sophisticated, but present in smaller numbers. Iran is not investing in new mine technology at a pace that offsets the US clearance advantage. The paradox of the Strait of Hormuz is this: Iran built its most powerful asymmetric weapon around a geography it cannot fully control, using ordnance technology it cannot fully maintain in a maritime environment that does not cooperate with static deployment doctrine. The weapon works as a threat precisely because it is never used. The moment it is used, the moment mines enter the water, the operational limitations of Iran's naval doctrine become visible to every actor in the system. And once those limitations are visible, the deterrent value of the threat diminishes in ways that cannot be reversed simply by recovering the mines or issuing a statement. This is the strategic cost that no inventory list can capture. Iran spent decades building a threat. In 11 days, it spent that threat and got nothing for it. We make original videos from scratch and animated by humans, so please subscribe to not miss a